EWP 2018 Philmont Scout Ranch. We just finished laying out a diversion. Basically, this is the watershed. I haven't delineated it to see how big it is and to see how much water it'll shed. The imminent threat downstream, thus justifying the diversion, is behind you. We got basically a cabin that the Philmont Scout people use. And so you can see just by looking on the ground upstream of the cabin that all of this sediment started going towards it and it's building up against the back of the wall. And so that we can catch sediment and slow down water, that's why we're building a diversion. So right now the stakes, the station 0+00 up there, and essentially we're dropping 1/10 for every 100 to this stake here. That stake's 92 feet away from station 0+00. So the diversion's gonna be built to that last stake, and then we're gonna have, we don't want the water when it hits the diversion to go around, so we're gonna put a kicker basically 50 feet away from here, and then the water, when it hits the berm, will then slide against the kicker and go out into the trees and onto the road over there. We don't want it to come around here and go onto their parking lot here. So that's the point of doing that. So essentially what we did to start was we had to locate where the diversion would be. And so we located it, if you look this way, in such a way where it's keyed into the bank right there. I don't know how high the berm has to be because I have to run the hydrology to see how high it has to be. The height of it is going to be based off the velocity of the water coming down and the flow. So those are the two variables. The flow and the velocity determine the height of the berm, and basically I have to delineate the watershed, and let's just say I come up with 80 acres. After I figure out the 80 acres, I have to do chapter 2 hydrology to figure out what the CFS of the water, the flow of the water is when it's going to hit the berm, and the corresponding velocity. So that water is coming down at a certain velocity fast. This is a 12% slope. I have to just check to see if even our diversion charts go to 12%. It may not, but I believe that the Chuck Caruso diversion charts go up to 12%. So I'll go to use that diversion chart, figure out where 12% is on that chart, and then finally the corresponding velocity, and Q determines the height. So in a nutshell, that's what we did. After that, we laid it out. We set up our laser level right there, and our intern Aaron and me, basically Aaron and I, we shot these stakes with rod. Let me bring that over here so you can see. This could be. So using this rod, this is the survey rod, laser levels behind us. I needed to shoot each one of these points, and the way you use a laser level, most of you guys have used it, but basically you set up your reader on the top, level with the top flush here, point it towards the laser. In the back you have readings of the rod, and essentially I'll first of all find where it's going to hit. When it starts beeping, fast means to go down, so this is the slow beep, so it needs to go up. Now that's a constant. So if you look at my reading here, it's 8.02 is the reading, 8.02. If it would have beeped right here, it would have been 8.25. 8.21, 2, 3, 4, 5. So you read the bottom of that. So we shot all of these stakes, got the corresponding reading, and before we even did that, what we needed to do was figure out if I want this to be dropping and flowing this way at 0.1 per 100, and if this is a 100-foot long berm, then basically I want it to drop 0.1 per 100. So from that stake over there to here, you're dropping from there to there. That's a tenth. That's all you're dropping. So you can see that it's very critical to get the shots pretty much right on the money. When the water hits this berm, it's going fast. When it hits the berm, it's slowing down and gently at a 0.1 per 100. So 0.1 difference between here and there. It's just gently coming this way, and by the time it gets here, it's gonna go against this kicker and be very slow. And if we wanted to make sure that if the 0.1 per 100 wasn't enough, we could put some rock here, and when it hits that rock, it'll slow down even more. But we can do that. There's grass here already, so the grass will serve the purpose of slowing it down. You can see right here all the sediment got caught by the grasses and slowed it down. And then lastly, what we did, Aaron and I, was I measured, I went upstream. Let's just say I was right here, and I measured 100 feet that way. I shot this shot, and it was 0.5, and then 100 feet over there is a 12.6. So basically a 12 foot difference between here and here over 100 feet. So that's a 12% slope. So that's how I figured the slope. So 12 feet difference, elevation from here to 100 feet. 12 divided by 100, rise over run, was 12%. And then after we shot all this, actually let me backtrack. When you first start your survey, you're supposed to go shoot the benchmark. So here's the benchmark over here. Go ahead and pause it. And it should be starting at the same. Okay. When you first start your survey, any survey, you want to put your benchmark out here. I have a 2x2 hub right here, and I shot that, and I read initially, actually let's look at my survey notes. Initially my elevation at my benchmark, I need to put BM there, was 165 was the reading on the rod. And then I went, and as far as the berm goes, let's just face it this way because this is the orientation. North is that way, so I put a north arrow. So like I said, I'm going to start from the beginning. When you start your survey, you put the date, the temperature, the weather, who the surveyors are. Aaron was the rod man, I was the note taker. And I drew a quick sketch of the berm from station 00 to station 88, and there's the kicker. So water's flowing this way. And it's going to drop from this side of the berm to this side of the berm, 0.1 per 100. So basically come out to be 7 hundredths it's dropping over 92 feet, 88 feet, sorry. Oh, sorry, 92 feet. So I shot station 0 plus 00, station 60 in the middle, and 92, station 92, and then the last station I shot here. And all those elevations were corresponding on the rod readings are this, and the actual elevations were this. Once again, you shoot your benchmark 165. I denoted my benchmark as being a 2x2 hub, wood hub, and the elevation is 165. I can probably draw that tree so that they know it's a tree. What I got to do now is measure from a known point how far it is from benchmark to a known point, so that the person that comes out here, if it's not me laying out or checking out, they can know how far it is from a known point to the benchmark. We shot all our points. Shoot your benchmark 165. You always start your benchmark at 100. 100 plus 165 is 10165. That's my HI. Every shot thereafter, you skip a line always, is a foresight. And every time you get a shot from your rod, you can get 10165 minus 389 to get your planned elevations. 10165 minus 792 is 9373. So relative to this benchmark, this point 060, which I haven't labeled, is at 93.73. So it's about 6.3 feet lower than the benchmark. So that's how you get all your foresights. When you're done with the elevation, we set up once, but that doesn't mean you don't close out your survey. A bulletin just got out, you got to do it. And we've always had to do it, but we weren't doing, so now we got to do it. So basically you got 100, 0, was what I started at. I then shot the benchmark again, and it was a 164. It was a 165 before, it was a 164 now, so it was an error of 0.01, so 1/100th of the error. You do that closing out of the survey so that you make sure your equipment, the laser level, didn't get bumped or it's calibrated correctly. So that's the quick on laying out a diversion. You got to first figure out where you're going to put it. Then you figure out what slope you want it. I like 0.1 per 100 because it's very, very minimal slope. And after you lay out the stakes, you're going to shoot the corresponding stations that you want to shoot. Shoot your benchmark from the beginning of the survey and shoot the benchmark at the end. Check it. When they build this diversion, they're probably going to use either a bobcat or a backhoe, and they'll get the material from the backside of the berm. That's where their borrow will be. If they don't have enough borrow here, I'm approximating this diversion to be about 300 to 400 cubic yards of earth. So that's 30 or 40 dump truck loads. So if they can't get enough material, if they can't get 30 or 40 dump truck loads out of there, they probably can't. They're gonna have to bring in fill material. 30 or 40 dump trucks will have to come in here and bring material in here. So that's the inside on diversions. If you have any questions, post it on the YouTube comments below. And thanks for watching. Thank you. Goodbye.